Hi everyone, it's my honor to do the presentation for my project called Comprehensive Profile Modeling. I worked on this project with instructions from Dr. Selina and Dr. Menghan. Now I will briefly introduce the background of this project. As we know, face analysis has received much attention from the computer vision and pattern recognition. Current research progress has promoted us to solve problems about face recognition or face detection for some realistic stimulus, like robot service. As we know, the success of the service robotics decisively depends on the ability to extract accurate information from face images, like identifying gender, age, or emotion state. Till now, despite significant recent advances in the field of face recognition, all of the related works or classifiers are only limited to one specific facial feature, like gender, age, emotion, and so on. But there is one problem on this. All of these models cannot be applied into each other. Based on the previous works, it has demonstrated that features fusion plays an important role in image detection or some other applications. By doing researches, we got some motivations and hypotheses from them. Firstly, it is possible that features extracted for one classification task may have useful information that another type of features extracted for a different classification task misses. That means features extracted from different tasks based on same image may have complementary relationship. Secondly, it is possible that different features have overlapping errors. That means different tasks need same kinds of features to do the prediction or classification. And thirdly, one feature may have an error that other features do not cover. Therefore, if multiple features are combined to do a classification task, the fusion feature may outperform individual features. And this is an image to show the relationship among different features as we illustrated in previous slide. We can see that different features have overlapping areas and the different features may have complementary relationships in this image. And in this project, we proposed a deep learning based feature fusion approach for facial computing, including face identification, or we can call face detection, as well age, gender, emotion, or race detection. And then we will compare this approach with other individual tasks to verify whether we can achieve higher accuracy through deep learning models. And actually, we strongly believe this approach will be much more efficient and accurate than other individual tasks. Now I will introduce the related work in this project. As we know, deep learning models such as convolutional neural networks, CNN, have shown higher accuracy in face recognition, especially in image detection. And in this project, since we try to prove the power of face features extracted by deep learning models, instead of focusing on challenging the state of art or improving face recognition network architecture. So we will use a famous CNN architecture called VGG as our own architecture. Firstly, we'll train 6 different classifiers for classifying face images based on race, age, gender, emotion, beauty, and identification. And all of the training are based on the same CNN architecture for comparison. And secondly, we need to extract multi-task features from trained model. As we know, features will be presented as vectors. So we only need to extract the vectors from the last convolutional layer, and then we need to aggregate 6 cans of features or vectors into a large vector to present our fused features. And finally, one cross task feature training will be conducted to show the value of aggregate features extracted from multi-tasks. At the same time, it will show the performance of our project. And this image showed the neural network of our project. And in this new edition, we have 4 layers. The first layer is simply the concatenating layer or aggregating layer, and followed by 2 fully connected layers. Then we will have the output layer for the labels. Again, we will train these layers for each of the ID, age, gender, race, emotion tasks using the fused features of the training dataset, and finally test the fused model for each task. And for this project, we hope we can get some results as follows. The first result that we hope we can create a deep learning-based feature fusion approach for visual computing. And the second, we hope this feature fusion approach can achieve higher accuracy through deep learning models than other individual tasks. And all of this are my presentation for the project. Thank you, and I appreciate your time. Hope you have a wonderful and safe time.